we are going to be solving a problem of credit risk. So looking at this data set, we have various individuals that have made intent requested for credit, and so we're looking at their behavioral patterns from a specific organization. So person of age 22 who earns an income of $59,000. Yes, he stays in a rent. Employment length 123. Oh, good. Loan intent personal. Loan amount is requesting for $35,000, and the interest rate is 16.02. The organization is giving it to him. Loan status, or was it given to him? Yes. 1 means yes, 0 means no. Loan percent income, person credit history length. So the institution has tracked the credit history length of this person, and did this person end up defaulting? Y means yes, N means no. So we have information like this for 32,580 persons who have made intents for loan in time past. Some the loans were granted, some the loans were not granted, and loans for different reasons. And we have the institution has been able to put together gracefully if they defaulted or if they did not default. Good. So before we jump right in building models from this data set, I would like us to visualize the data set, and let's see some interesting patterns around it, especially Autogon cover plots. I'll give this some seconds to run. This is the result of the data visualization. So I'm very interested in the cover plot. Oh, the cover plot is already showing us some interesting insights. That person employment learns. So we can see that most people who worked longer, according to this data set, they actually acquired a mortgage. And yes, house owners also worked long, but not as long as mortgage owners. So I guess so they were working long enough to be able to pay off their mortgage. Oh, let's look at another. Okay, debt consolidation, education. So home improvement. So a good number of the loan went for home improvement. So let's look at employment length and personal income. Okay, so we can see this is scatter chart. Let's look at how about the loan amounts, how about loan status. Okay, so this data set also shows us that the people who were given loan, that's one true. So people who were given loan or that their loans were approved were not basically people who worked as long as possible. Good. So now that we've seen some of the statistics, let's just hop right into building our model. Loan status and loan percentage income. Okay. So okay, and interest rates. So there was a lower, so the higher the interest rates, the more the institution approved the loan. Oh yeah, cool. So let's hop right into building our model of this data set. So we would go ahead and create a project, and we'll call the project credit risk, and create this project. On Studio, there are two ways you can build a model: a machine learning or a deep learning model. So it's either you go through the no code, go through the AutoML route, or you go through the no code AI IDE route. So AutoML route, in 3 steps you've built a powerful model, and this route you have to build the model manually yourself. So for the sake of this tutorial, we'll go first through the Studio Wizard route. So we'll go ahead by launching Studio Wizard, and we'll select credit risk data set, and we'll give this some seconds to run. Oh, great. So from this data set already, we can see columns like loan percentage, percent income has a very high importance, same as the person's age, person income, employment learned, loan amount, credit history. Great. So we'll just hit on the next button. Now, if you look at the data set, what are we trying to predict? We're trying to predict a yes or a no. So this is simply a categorical variable. So we're trying to predict this particular column. So meaning we're building a classification model. So we simply select default, and we'll call this credit default, and we hit on the train button. Oh, great. So our model has been built, and we have a model accuracy of 0.83%, 83, which is 83%, and this is beautiful. Another way to calculate this accuracy is simply you sum this and you sum this divided by the sum total of every single thing, and this is beautiful. So we can so you can look at the feature of importance, and we can see the loan interest rate has a very high significant importance towards predicting if the person gets to default or not. Interesting data set. So let's go ahead and do some prediction. So we start first by predicting some records off of the training data set, and a simple way to do this is to, I have here the data set opened on my browser. We can copy, for instance, this first row. We copy this. So now so for us to make a prediction, we're trying to predict this last column, either a no or a no or a yes. For us to predict it, we're going to copy every single thing before it, yes. So we are going to use this to inference our model, but on Autogon, Autogon does not accept this like this. You have to convert it first to a data set. So you click on quick predict, and you can select the project or another project, and you click create data set, paste what you've just copied, select one dimension, and generate. Copy the data set, then you can come down to your model, paste what you've just generated, and voila, we have a prediction. Now we copied this and the prediction was a no, and let's see what our model was able to give us. And our model was able to give us a no with an accuracy of 0.6. Now let's copy another item here. Person of age 22, 6,500, personal income, and he wants it for a rent. Let's check if it's going to default, and he wants it for an educational reason. Let's see if our model is smart enough to tell if this person is going to default. and we paste this, select a one dimension, and we generate the data set. Copy this, and we'll come to our test data set and paste it, and we predict again, and our model says no. So this person would not default with an accuracy of 0.5, which is beautiful. Now we are going to do some other inference. Okay, let's pick this guy that says a yes, and we click on this, paste it one dimension, and generate a data set. Copy this, and we paste it here and click on predict, and our model tells us a yes. So our model is actually very performant. We are going to copy just one more. Let's copy this guy that says a no, or we can scroll down, which doesn't matter. Let's copy this guy, 821, and we'll click on create data set again, paste this, select one dimension, generate, copy data set, and we come to test data set and paste it and click on predict. And what does this tell us? A no, with a 0.95 accuracy. And you can see, and this is actually a no. So our model is actually highly performant, and we can already take our model to production. So one of the ways to start making use of this model right away, we need to create a pipeline. And so a pipeline is so you can inference your model from your API or your back office. But if you don't have a back office, there's no need to create a pipeline. If you're going to be interacting with your model directly through this route, there's no need for a pipeline. So let's just go ahead and create a pipeline right now, and we'll call this credit default AI. And this is actually an AI model. So create a pipeline, and beautiful, now we have a pipeline. So we can then go back to our project details page, and we can see our pipeline. And yes, we can also test our pipeline through quick predict, and we can test our pipeline through our postman or through our back office. So let's first try the quick predict part route. We click on the credit risk, we click on the credit default. Right now we can create another data set. We pick this particular observation, and create a data set, select one dimension, and we generate. We can come to this input link, insert, and run model. We select pipeline, and we select the pipeline we've just created, and we click on predict, and our predict comes with a no, which is beautiful. And this is actually a no. And to inference this directly from our API, what we need to do is to so we copy this pipeline ID. I've just copied the pipeline ID, and we take this to our postman. And I'll simply update the flow ID of this existing project I have here, and I'll come right here. I can pick this same observation or another observation. I pick this right here, and I create a new data set off of this, and I copy this, come back to my postman, and I update the data set here and click on send, and the model gets inferenced, and we can see our prediction URL, and by the time we open it, we get a no. Now I've showed us how to create a model on Studio Wizard and inference this model on both quick predict and on our postman. So the next thing I'm going to be showing us is how to build some more other models and assess more other accuracy leveraging the Studio environment. Join me as we explore the Studio environment and build a couple of more AI models off from these data sets. Here is a project I've built off from Autogon Studio from the datasets, from same datasets. And so just some quick things we need to fix here on this dataset. So we can see column 012, column 2 is actually a string data. We need to convert it into a numerical data, what our model understands. Same as the loan intent, we need to convert it. Then also we can see there's a column 10 which is empty, and we need to fix that. So good. So the first thing I dragged in here is the feature sampling. So feature sampling, we are splitting our data set into the x and the y. X meaning independent variable and the y meaning dependent variable. So now if you look at our data set here, all of this is actually the independent variable, and this is the dependent variable, what we are trying to predict. So we're trying to predict if the person is going to default or not. So that is actually the dependent variable. Every other thing is the independent variable. Good. And one way to split on Autogon AI is by bringing slicing. So slicing, you can say I entered colon, comma, colon, -1. This means the first column means all the rows, and the second means all the columns except the last one. Now, for the y boundaries, the first column means all the rows, the second column means that's the -1 means just all the rows for the last column alone. Now, it is quite worthy to note that on Autogon AI, you can also reference, you can also specify your x boundary and your y boundary via specifying the numbers. That's the column number. So you can enter 0, 1, 2, 3 till 10 and enter 11 here. It works good, but slicing is just a fast way to get this done, and you can always read this on Autogon documentation how you can get started with slicing. Now, we brought in the drop column. Why? Because okay, let's look at the feature sampling. As you can see, x value has been separated from y value. Now there is the column 10, which is actually empty, so we need to drop that guy. So that's what we're bringing in the drop column, and we're specifying for the x variable drop column 10. Beautiful. Now after we've dropped column 10, if you look at the drop column for the x, because the x value has actually been updated, there's no more column 10. We need to label encode index 2, and we need to we need to encode index 2, and we need to encode index 4. So good, we can't use label encode because it's not a binary categorical item. So it's more than 2 categories. There's rent, there's own, there's mortgage. So we're going to use a one-hot encoding. And if you look at index 4, there is personal, educational, medical, venture, educational, personal. Yes, it's more than 2, so we're going to use a one-hot encoding. So we brought in data encoding, and we specify one-hot encoding, selected variable, x variable, pass through, and then we selected index 2 because it's actually index 2 we are wanting to one-hot encode for the house the person stays. Good. And then yes, we saved the weight. Enter a value here to save the weight. Now you only enter this if you are going to be building a pipeline off from this project. So because we're going to be building a pipeline, so we entered a save name right here. Beautiful. Now we brought in another data encoding, and this is because after the first encoding here, let's look at the result of the first encoding. I see, beautiful, it has been encoded, and this is the result of the first encoding, which is great. From these columns have been introduced. Now we need to encode column 7 in same light. So now if you look at the next encoding, we then specified column 7, and we specify the name we are wanting to use to save the weight of this encoding. Now, like I said, it's important we save the weight when we are building pipeline. So if you click on this weight, we can see we already have some weight saved here already. Beautiful. Good. So after we are done with encoding, we can look at the value of X, and we can see it has been encoded, the house it stays, and the reason for the loan has been encoded. Beautiful. Now the next thing is to split our data set, because we're already getting ready to wanting to train our model, and yes, we dragged in the data split block. Now from here, so we dragged in the data split block, and now we specified a test size of 0.2. 0.2 means 20% is allocated to the test data set and 80% is allocated to the train data set. I will specify a random state of 0. So if we look at the variables region, we can see the train data set already has an 80% of the overall data set, and the X test already has a 20%, you guessed right, of the overall data set, which is very beautiful already. Now after we're done with data splitting, now why is it important to data split before we feature scale? And this is because we don't want the weight from the train to leak to the test, so we're trying to avoid a weight leakage between the train and the test variable. Now once we're done with data splitting, we can now bring in feature scaling. Now the two data set of interest to feature scale is actually the X train and the X test, and this is because we're going to be building our model off from the train, and we're going to be using our model to we're going to use the X test to validate the accuracy of our model. Good. So for the feature scaling, I specified a min max scaler, and I entered the boundaries. So these are the regions that need to be scaled, and so in which you can always enter those regions using slicing. So you can see I specified these, I specified these, I specified 13, 14, and 16. And if you look at feature scaling, you can see each of the boundaries are specified. Then don't forget to save the weight. Very important that you save the weight, because we're going to be building a pipeline off from this project. Good. So now I brought in classification, automated machine learning. So if you look at automated machine learning, there's classification. Now why? Because this particular block runs multiple classification algorithms and so let's look at the result of what it ran. If you look at the sprint statistics, we see that number of successful targets it ran was 30. Good. So it ran 30, and the best validation score is a 0.82, which is actually beautiful. Good. So so we actually, and we can always look at the leaderboard, and we see that these are the ranking, and the highest rank item here is from the random forest. Beautiful. Now so we ran this, then we brought in predict. So here, when you bring in the predict block and you leave the test data blank, we are simply saying Autogon should use the X test. So here so you specify default and you enter the model name. So we're saying, hey Autogon, predict the X test and give me a Y pred. So if you check the result of this block, you see that we already have a Y pred, which is actually beautiful. No, yes. And if you compare it to X test, and see why no, which is yes, no, good. So then we bring in our metrics. So our metrics then tells us the level of accuracy our model performed on the X test, and from the X test we're having an accuracy value of 0.819, which is approximately 0.82. So meaning our model following this route has an 82% accuracy. So now, good, beautiful stuff. Then with them, so I tried a different route also, bringing in automated structured data classifier, which you can find automated structured data classifier. Good, automated structured data classifier. This is it. So I dragged in this here, and I specified a max trials of 2. So later you want to specify a higher amount of max trials, so the model training process can try out multiple hyperparameters towards getting an accuracy that is very high. And I entered the name of the model ADL, and I specified oh okay, run for 10 epochs. Good, you can play with the number of epochs. Here. So I entered 10 epochs and I ran this, and it took a little while. Then I ran the evaluate at batch size of 10, and when I was done, I got an accuracy of 0.82, which is 82%. Beautiful. And remember, also on our Studio Wizard for same project, we had a similar accuracy. We had an accuracy of what? This was credited for one accuracy of 83.2%. So meaning, so the model we built off from our Studio Wizard outperforms the model we built from the automated classification learning, and outperforms the model also built from the auto deep learning block that we dragged. Beautiful. So now it's time to create a pipeline also from here. We've created a pipeline on Studio Wizard and Inference, so let's create a pipeline from here. And before we create the pipeline, I want to take note of all the data preprocessing steps that was used. So if you look at this, we dropped column 10 1, then we encoded column 2, we encoded column 7, and we brought in feature scaling. So for me, the way I like to do this, when I have multiple blocks having different informations I need to cater for, I always tend to open this on a new tab so I can build the pipeline from the new tab. So to build a pipeline, you click on the switcher, and you click on add. So we're going to call this studio underscore pipeline, and we save it. So good, we can then look at here. So feature scaling, we don't need to bring in feature sampling, we don't need to bring in this. Drop column 10, very important. We'll bring in the drop column and we specify column 10. Good. So the next is data encoding, index 2, house width. So we specify here also data encoding, index 2, house width. Beautiful. Now the next is data encoding, index 7, reason width. So we bring in data encoding, connected, index 7, and we specify the reason width. Good. The next thing is data splitting. We don't need to do data splitting on the pipeline. And the next thing is feature scaling, and for each of these boundaries, and the weight is feature scaling underscore 2. Beautiful. So we're going to bring in feature scaling, and we specify the boundaries as well, and feature scaling underscore 2. Beautiful. We're making progress. Then the next thing we progress towards building the model. So we need to drag in. So actually this model had a higher accuracy, 81 and 82K ADL. Good. So the auto deep learning had a higher accuracy, so we're going to bring in the model predicts and connect it to feature scaling, and ADL has an higher accuracy. And when we are done, we go ahead and run save for every single thing. So beautiful. Now that we are done with our pipeline, we can go ahead and exit studio, and we can see we have studio pipeline here, which is beautiful. So remember, we also inferenced our model using the credit default. We built this pipeline off of Studio Wizard. Now let's go back to quick predict, select credit risk, and we can select the credit default, and let's see how we can play with the both models. And good. So we can select this same record and we build the data set off of it. Good. And we will now try to inference the both models. So we inference credit defaults, and credit default gave us a no. So let's now try to inference the studio pipeline, and the studio pipeline gave us a no, which is actually beautiful. So this is how we can build interesting models that makes very interesting data-driven decisions in split seconds. So we can hop back to our project, and remember we've tested this other model from our Postman, so we can go back to our Postman environment, and we enter this new model pipeline ID, and we inference for the same data set. And when we open the data set, we can see, and what we got is actually a no. So beautiful. So this is how we make very interesting data-driven decisions, and beautiful. We're able to build 3 models from this project, and with the accuracy of 83.2%, 81.9%, and 82.2%. Thank you very much.